Hey, hello everyone. This is Gaurav here, your friendly data architect, and today we are going to discuss about an interesting topic, which is why do we need a separate storage and a separate compute layer? Okay, so this is something the new architectures as well as new tech platforms have been following, right? If you have worked previously on databases, data warehouses, or even Hadoop, you would remember that the storage and the compute, these two components used to be tightly coupled. So let's go back to the Hadoop days, right? We used to have a master node and there were multiple data nodes, right? Data node 1, data node 2, and what did this consist of? Okay, so data node consists of a compute, a RAM, and storage disk, right? Similarly, data node would also have a compute, RAM, and a storage disk, right? So compute was like, let's say, let me change the color. So let's say this was of 16 week course. Okay, 16 week course of compute, here also 16 week course. And let's say the storage, you had multiple disks, right? You used to have some 10 to 12 disks. Each disk is of like 2 TB. So let's say you have a 24 TB disk available here, total storage, and here also. Now, if you have already used almost like 40 TB or 44 TB of the disk space, and you still need another 10 TB or 15 TB, 20 TB for your processing. Now the only option that time was to add another node, right? You have to add another data node to scale your storage. So let's say this will again come with compute, RAM, and storage. So this will give you another 24 TB. Okay, so used to happen is, so even if you want to scale your storage, you need a complete data node which came with compute and RAM also. So again, you will get additional 16 week cores CPU, which was not really required. Now it's not something, right, you are getting it free. You are paying for this complete node. Okay, so and storage are generally cheaper, compute are more, more costlier, right, these days. So unnecessarily you are going to spend on compute as well as RAM. Now this is the problem with the traditional architectures where storage and compute are bundled together or tightly coupled. Uh, so independent scaling was one problem. Also, the second is this whole thing, right? It eventually made that appliance costlier, right? When we talk about appliances of warehouses, right? It would make that whole ecosystem much more costlier, right? That is the reason we started shifting. We, as in the data world, has started shifting towards separation of the storage and the compute layer. So let's try to understand what happens in this case and how does it help. Let me get rid of all these things. Okay, so now if you have a separate storage and a compute layer, so what are the advantages? Let's say you have a separate storage layer and then compute is separate. Take example of those who have worked on Snowflake, Databricks, Lakehouse architecture, right? These are the ones who follow this kind of a scenario where your compute and storage are separate. Okay, what happens in this case, right? Your storage is generally the cloud object storage like S3 or ADLS or GCS, right? Your storage is here, and then you can have a separate compute engine. So if you have worked on Snowflake, you would know, let's say you have Snowflake on AWS, the ultimate storage, though you are putting the data into Snowflake, it is eventually storing it on S3. Okay, and then you will have compute of different sizes, right from extra small, small, medium, large, XL, maybe up to 4XL, right? You can have your independent scaling. So you can create different clusters where you can have a compute engine with excess, you can have another compute engine which is medium. All are taking data from the stores, same storage. Okay, so there is a single storage tier from where you can take the data. This is how the lakehouse architecture also works, where you have a separate compute, separate storage. Okay, you don't have to worry about independent scaling of this. So with this concept of having a storage and compute as two separate entities or separate components which can be scaled independently, it gives you multiple benefits. One of them is this independent scaling that we spoke about. Now, if you look at the lakehouse architecture, right, where your storage and I mean the compute can be anything, right? You don't have to really worry about any proprietary compute engines also. So what I'm trying to say here is you have this storage layer, and since your compute is separated, you can have any compute engine, not just a specific compute engine provided by that, that particular product vendor. Okay, let's talk about Snowflake, right? If you have implemented Snowflake with the native tables, right? Previously, before Iceberg and all came in, right? So that time we would take the data. Okay, we would copy it into Snowflake. Let's say you have a data, you have a CSV file, you would copy it, right? You will have to copy this data inside Snowflake, right? This would go inside Snowflake. And then you are using the query engine provided by Snowflake, right? You have to use the query engine provided by Snowflake. But now if you see the newer, with the new features, let's say if you are storing the data as iceberg tables, right, on S3, you can use other engines also, not just Snowflake. You can use other engines like Spark. Okay, same is the case with, the typical lakehouse architectures, or if you have explored things like Microsoft Fabric, if you know what it is, right? One lake, and maybe I can do another video sometime about it. But those who are already aware of this, right? One lake is nothing but a single storage layer which is built on Delta plus Parquet. Okay. And then you have different experiences, right? Synapse Data Engineering, Synapse Data Warehouse, you have the Data Factory, you have Power BI. All of them are taking the data from this single storage only. So here also it's a separate compute. So, right, separate compute, single storage. You just have to write the data once here, right? Once you have loaded data, all these engines can use the same data. Now, this is the benefit that you are getting because of this separation of storage and compute. So this is one of the fundamental concepts, right? Whether it's a lakehouse architecture, all these new platforms, right? These are all using this concept to get that flexibility or the freedom to use any compute engine that they want. Now with this, it also becomes easier to share the data with outside, right? If someone is not using this particular platform, right? Let's say you have the data on the cloud object storage, and you don't want to use the same engine, native engines provided that by that cloud, any other engines is fine. Or maybe you'll have to explore a bit more about the open table formats and how all those things work. But then it is because of this separation of the storage and compute. So to wrap up, right, what it really means and what are the benefits. So separation of storage and compute is where you separate both of these components so that they can be scaled independently. You get the freedom to use any compute engine with the storage. You can build a single storage tier with multiple compute engines, as we saw in case of Fabric. It will help you to create an open data platform where you can easily share the data with others. You don't really get locked it into any vendor. You are free to use the compute engines of your choice. And as discussed earlier, because you are using the cloud object storage, right, you get all the goodness of cloud object storages like S3 ADLS, right? Scalability, availability, durability. Plus it is much more cheaper as compared to the traditional storages used in data warehousing appliances, which used high-end hardware as well as proprietary storages. So all these benefits, right, are you get because of a separate storage and a compute engine. So try to understand these fundamental concepts where when you are building a new data platform and you are trying to learn the new technologies. Most of them have started using these concepts, and most of the features are based on these concepts only. I've also written a detailed blog on Medium of regarding separation of compute and storage. If interested, you can have a look at it. And if you still have any more questions, you can connect with me on Topmate. Thank you.